Hi, this is Mike, WB4HUC, and this video is going to be a little bit different. Um, One of the things that I like to do is run the radio station from the computer, not totally, and I don't do remote operation or anything like that, but sometimes I like to run the equipment sitting on the desk here from the computer. That way I can do the screen captures and the videos and things using uh, software, and capture things that are displayed on the screen. So, um, and sometimes I've written my own software to accomplish some task that wasn't already being done. So I think one of the things that I've demonstrated is the little program I wrote to copy the logbook entries from WSJTX over to my main logging program. There's a piece of software that sits in between WSJTX and my logging program, and whenever a log entry is made in WSJTX, it automatically gets copied into my main logging program, and I don't really have to do anything. Well, there's another bug I've had for quite a while. I've owned an Elecraft KPA500 amplifier and a KAT500 tuner for about 8 or 9 years. And I've always wanted to write a piece of code that would just show me the status of the amplifier. I don't really want to run the amplifier from the software, but I would like to, um, if I'm running the transceiver from software, I'd like to be able to keep my eyes on the computer screen and see what the amp is doing. And so I've done that, and just wanted to show a little bit of that today. It isn't much to look at, but I thought I'd go into a little bit of an explanation of how this all came about and that kind of thing. So if we go back to the software I wrote for the logging program, I did that in a language called Rex. And Rex came from the IBM mainframe, which is my world. All my professional life, I was a software developer or some other related job in the IBM mainframe world. And that's where Rex started. It was invented at IBM, but now it runs under Linux, Unix. There was a version that ran on the Palm OS devices, the Palm Pilots, if you remember those. I think there was a version that ran on the Commodore Amiga, and of course MS-DOS and Windows, and still is. So, and it's an interpreted language. You don't compile it. You can write it and test it, write it and test it without having to compile anything in between. And that's what I wrote the logbook program in, or the program that copies logbook entries, is in Rex. And that's this guy right here that you see in this editor. And I'll put in a shameless plug for something called Ultra Edit. I've been using it for something like 20 years or more, and I like it a lot. Anyway, I'm not going to go through the program, but this is just what it looks like. Setting your variables here, setting something called compound variables here, which are very useful in Rex. And here, writing out the little heading to the program, uh, and then um, here's a little loop that we do to execute some things, and here's the main loop of the program. And just like it says, it runs forever. The only real way to shut down the program is to close the window that it's running in. So, and then here are some subroutines that are called by the code up here to perform some jobs. There's one, there's one. And you can see there's little line numbers. There isn't even a go-to statement in the language. It's a little more structured than that, so you don't have to tangle yourself up with go-tos. And anyway, this is it. It's not a very long program, 300 lines, as we see here, but it works, and it works well. So that's one thing I did. So the other thing, and this is the one I'm really here to talk about today, is the program to get the status of the amplifier. So I wrote it in something called BBC Basic. So I went back to the basic programming language for this one. And I've been looking for something simple to write code in, easy to use, that kind of thing, that would do what I wanted to do without having a lot of overhead to it. In other words, I didn't want to have to include other pieces of software like a database of some sort, or any of the complicated stuff that some of the Microsoft programming languages do. I didn't want that. And this one, I've been looking for this for a long time. Now, this is not new. This has been around for a while. I just didn't know. So I've stumbled across it. I downloaded and it's an interpreted language as well. Um, I downloaded the interpreter and uh, studied the language a little bit. I've written basic code in the past. 40 years ago in the early 1980s, I had an Atari 800, and I actually wrote a packet radio terminal program for the Atari 800 to connect to a terminal node controller, if anybody remembers packet radio, and that worked pretty well. And I wrote another program for my Palm Pilot. I had a handspring visor, and I managed to find a cable that would connect to a serial device, an RS-232 serial device, and I wrote a program to control my Tentec RX320 computer controlled shortwave receiver with the Palm Pilot. So I've been writing code for a long, long time for little projects for myself. And uh, I've written a lot of stuff. I worked for a company called SAS Institute for 25 years. I've written a lot of stuff in the SAS language, mostly for processing logbook information. Uh, it's got excellent character parsing abilities and other things that make it suitable for that kind of work, and a lot more complicated than that too. But I use SAS a lot while I was working for them, but I retired a couple of years ago. Anyway, but I wanted something simple that was sort of self-contained that I could just run and not have to worry about anything else. And I found this, and I'll include a link to the BBC Basic for SDL website so that if anyone's interested, they can download the language, install it, and there are tutorials available, and there's all kinds of information out there about this. So here's the language. Of course, it's basic. So if you've ever programmed in basic, this will be familiar to you. Although, like most dialects of basic, there are features unique to this dialect of basic. This VDU command for establishing a window to output stuff to. Uh, and you notice there's no line numbers here. If you ever worked with the old, sorry for that interruption, there was an Amber Alert or something that went off on my phone. If you've ever worked with the old basics from the old 8-bit computer days, you know that you had to have line numbers, and if you wanted to skip to a different section of code, you had to put a go-to statement in to skip. Well, this is a lot more sophisticated than that. So this one we will run through just briefly, and then I'll demonstrate it. So this is a command that, as far as I know, is unique to BBC Micro Basic to set the screen size, and I won't go into all of it. And this is a statement that tells the program to, when I close the window that it's running in, go to this procedure and execute the statements in that procedure. So this is the last thing that'll get done in the program. And then the user needs to enter the COM port number that the amplifier is connected to, and then the user needs to enter the baud rate that the amp is set to. So you enter those two things, and then we disable the cursor because we're not going to be inputting any data. So we don't need the screen cursor, and it creates a bit of a visual confusion if you leave it turned on while the program is running. Here we assign our variables. If you remember basic, the $ indicates a string. This indicates a number. I can't remember if that's single precision, double precision, or integer. I can't remember. Probably integer. And then these are the commands that we send to the amplifier. Elecraft made this real easy. Elecraft made this real easy. So all you do is you send a string of character data to the amplifier to tell it what you want, which is a lot easier than some things I programmed in the past that required some sort of binary coded decimal, or they required you to convert things into hexadecimal or whatever it might be. This is simple, straightforward text stuff, and these commands are all documented in the programming manual for the amplifier. And then here's the for the command that opens the COM port. These are the parameters. So you'll have in my case, it's COM port number 5. So it would end up to be COM5 colon, comma, no, a space. Then the baud rate that you entered in up here, comma, no parity, 8 bits, 1 stop bit. And then here's a heading for the screen, a little bit of self-gratification here. And then once we enter the stuff, we clear the screen, and then we print these 2 lines, and then we open the COM port, and under BBC Basic, if you return a 0, so this is a command to open the port, and it'll return a value into this field. Well, if that value is 0, it considers the port is probably already open somewhere else. So what we do is we put out the message, and then we tell the user to close the port and try again. If this returns something other than 0, then that's the I forget what they called it. It's not this. It won't be a number that's equivalent to the port number. It'll be a different number, but you use this number to address the port in the code that follows. So, and here's where we're going to execute the code to get the different information. So we're going to execute this procedure. Talk to amp. We're going to pass it the command that we saw up here. We're going to pass it one of these commands. So we're going to do this one command at a time. We're going to pass these commands, and then we're going to pass the text we want to print to the screen for each value. And then we're going to stay in this loop. This is my own little sort of a joke, I guess. We're going to basically stay in this loop forever. And the only way to stop the program is to close the window. And then, as I said, when you close the window, you'll go to that procedure that was named and execute the code that's in there. And the code that's in there just closes the port and quits the program, because we don't want to leave the port open when the program ends. And I think behind the scenes, BBC Basic would close the port anyway, even if you don't, but why not be safe? And then this is left over from an earlier iteration of the program where I didn't go to that procedure at the bottom, but I left it in here. If there's some sort of mistake, or if there's something that causes it to fall through, we'll still close the port and end the program. And then here, so a procedure is just a block of code within your program that you can call on. It's not in the main body of your program. It has to be invoked by calling it. And you may pass it values, you may not, but here we pass it values. But it's a sort of self-contained block of code within your program that you can use to do things, repetitive things mostly. So if there's anything you want to do more than once, there's no sense in duplicating 100 lines of code, to do it twice. Just put it in a procedure, write it once, and then call on it when you need it. So here we're defining the proc. We're going to talk to the amp, and then we're going to accept the parameters that are passed to us, which is the amplifier command and label. And these are probably global variables. I probably don't need to do this. They're probably available to the procedure anyway, but I coded it this way just to be safe. And then the bput writes to the serial port. So the number, port number, %, that's the number that's returned to us by the open command. And we're going to write that string of data. Now we got to read the data that the amplifier sends back to us, but sometimes I've noticed there's a bit of a delay in between the time the amplifier gets the command and the time the amplifier passes back the response. Now we're talking milliseconds here. We're not talking about, sitting there waiting 5 minutes for the thing to do, but a millisecond is a long time inside a computer. So I put this little repeat loop in here, and this value, so this value looks at the buffer, the serial port buffer, to see if there's anything in there, and he will report the number of characters that are in the buffer. Well, if that number is 0, then nothing's been returned yet. So we keep in this loop until the number of characters in the buffer is greater than 0, and when that happens, we fall through and we keep going. So now we're going to read the characters that are in the buffer, and the amp seems to be returning the response one character at a time. So we're going to execute a little loop here. So we're going to execute this loop for as many times as there are characters. So if there's 10 characters, we're going to execute the loop 10 times. If there's one character, we'll execute it one time. And then this number we're going to build. So, so if the response was 5 characters, the first time through the loop, this value is going to contain 1 character, and the second time this value is going to contain 2 characters, and eventually by the time we've read all the characters and added it to this value will contain all the characters. And now we got to parse the response. So what did it send us back? And we know what we asked for, but now we got to decide what it sent to us. So we're gonna do a little arithmetic here. So we're going to get the length of the command that we sent to the amp, because when the amp responds, it responds with the command that you sent it followed by the data, and we need to separate out the data from the command. So we're going to get the length of the command that we sent, and then we're going to get rid of the command part that got returned to us, and we're only going to keep what follows the command. And then there's a semicolon at the end of that string of data we get back. We're going to drop that semicolon. And then what we're left with in here is strictly the response to the command. Might be one number, might be some letters, might be whatever. So now we got to figure that out. What did we get? So as the remarks say, some commands send back numerical values instead of text. For those that send back numbers, we need to turn those numbers into something that is usable for the user that we can print out on the screen. Or we might just tack some information onto the response to make it a little more useful. So for instance, in the case of temperature, it returns the temperature in centigrade. I'm not sure why they don't give us a choice to choose centigrade or Fahrenheit, but it returns it in centigrade. Now, so basically I just take the response and I put a C at the end of it to make it centigrade. Now what I could do, there's a well-known formula for converting centigrade to Fahrenheit. So I could do that. In fact, I might, now that I've thought of it just now, I might go ahead and in here and I might just also convert this number to Fahrenheit for those of us here in the US and print out both, print out Fahrenheit and centigrade. So that's an idea. So amazing when you talk these things out, what you think of. So now we're going to build a statement, this case and end case, and we're going to examine the amp command. And if the amp command is equal to the operating status, we're going to follow this code. If it's not, then we're not going to do anything here. We're going to go down here, and if it's the command to tell us the current band, we're going to execute this code. And we're going to turn these numbers into this text and print out this text. If the command is to get the radio interface, then it's going to execute this code. And once it executes each little block of code, it exits down here at the bottom. It only executes one of these. It executes whichever one is true. So You can see here we're converting some numbers into some text, and you can see here that for the voltage and current, they're already in numbers, but they don't have decimal points in them. And I believe voltage is first, and then current follows it. But anyway, I just separate the two numbers out, put the decimal points in them, and put a slash between them, and then print out voltage and current. And put it in this value. So then at the bottom, we tell it where we want to print the line, and then we print the label plus the response. So we'll print out that text that tells us what the value is, and then we'll print out the value. Then we'll end and we'll go back up and do the next one. So once this block of code is ended, we go back up and execute the next one and the next one and the next one. And once we get through all of this, we just go back and do it all again. And we just stay here. So we're constantly polling the amplifier. And if you push a button on the amplifier, let's say to go to operate standby, you'll see that change in the display of the program immediately. If you change bands, you'll see that display in the program immediately. So it'll respond to any changes that you make through the front panel of the amp that I report on. I don't report on everything, but of the things that I report on, if you change those things through the amp, then you'll see it. So, and then we end this procedure, and then here's the procedure that we go to when we close the program. We simply close the port and we quit. So that's it. And this program is, I'll add some line numbers just so we can count how many lines there are. So this program is 176 lines. There's a spare line at the bottom that doesn't do anything. So this program is less than 200 lines. And if I remove the comments, which I would never do, but if I remove the comments, this program would be less than 100 lines long. But we need comments, because if I look at this a year from now, I won't remember what I did. So you notice there's no go-tos in here. The code's pretty clean. You can have blank lines in between lines of code to make it more readable. Lots of things you couldn't do in the old, 8-bit basic days. It's a pretty good language, and it suits my purpose, and that's what you look for. What is it that suits your purpose? And this suits my purpose. So let me see if we can fire this thing up. Sometimes the serial port is a little cantankerous the first time I power up the amp, but we'll see what we got. So I can run the program from here and you'll see it wants the COM port number. In my case is 5. And then there's the baud rate. Okay, and it didn't do anything. So I'm not sure. Like I said, I just turned on the amp a minute ago. So what I do in this case is I go to a more professionally written program, and I will go to the KPA500 utility that Elecraft gives us. And you're saying, well, if Elecraft gives you a program, why are you writing your own? Well, Elecraft program does things that my program doesn't do, and my program does things that this doesn't do. All I'm executing it for here is to get the serial port talking, which it did. And I don't know how it did that, but so what I really need to do then is in my code, figure out how to get the serial port talking. So we're going to shut this down now, and we're going to try this again. Same thing. There we go. So this is what you get. We print out the serial number, we print out the firmware version, we print out the temperature, like I said, 25 degrees centigrade. And I'll probably put a slash here and then convert that to Fahrenheit, put out the Fahrenheit. Operating status is standby, the current band is 20 meters. The PA voltage and current, 74 volts and 0 amps. Radio interface is set to K3. I'm using a K4, but that's what you set it to. The PC port data rate's 38400. The transceiver port data rate's 4800. So those are the things I report on. There's more that I don't report on, but these are the things that were useful to me. So keep an eye on the band number here as I push up. You can't see me push the button, but I'm going to push the band button on the amp. And you see it change 12 meters, 10 meters, 6 meters, nope, 30 meters. I hit the wrong button. 6 meters, 40 meters, back to 20 meters. So when I push the buttons, they have it now. I'll go to standby and operate, standby. And when the amp is in use, you should see the current go up. Hopefully the voltage won't go down. Hopefully they won't, put such a strain on things that it drops the voltage. The temperature will go up as the amp operates. The fan, you'll hear the fans come on if you're in the room. But anyway, it'll just give you a status, what's happening with the amp. And I wrote this strictly for myself. This is a learning exercise. I wanted to remember, what I used to know about programming in BASIC and writing and reading the serial ports, that kind of thing. And a lot of times what you do to write and read the serial port depends on the application or depends on the equipment you're talking to. So that's pretty much it. Oh, there is one more thing I'll show you. So like I said, to close the program, to end the program, you just close the window. Now, you'll notice over here, if you can read it, it says KPA500.exe. So this IDE has the ability to create an executable. So I can go here and the app name, and I can say create application, and it will create an exe file. So the person executing the program doesn't need the basic interpreter if he gets his hands on the exe file. You can just run it, and you can assign it to your desktop and put an icon on it, and then you can just double click it. So I've already done this, but I'll do it again just for fun. Create application. Application bundle created successfully. So we just created a .exe file. So now if I click over here, there we go. Port number 5, 38400, and there we go. So this is a totally self-contained exe file. So it'll do that too, which the old BASIC, there were BASIC compilers back when, but not what came with your old 8-bit computer, your Atari or your Radio Shack, your TRS-80, your Apple II, or your Commodore VIC-20 or Commodore 64, your TI-99, whatever you might have had back in the day. Those were interpreted languages only. Well, this one you can create the exe file. Anyway, I've been going on here for almost half an hour, so I'm going to stop now. But if you think you might want to write some code and you want something simple and it's kind of a throwback to the old days, from what I've seen of BBC Basic, it's going to suit my purpose just fine. It may or may not suit yours, but what the heck? It doesn't cost you any money. Download it, try it out. And as I said, I will have the link to downloading the interpreter. And it comes with the IDE, and it comes with a bunch of sample programs. There's a pinball game that's written for this. So if I go here and I go to load, if I go to it's under physics, not games, but pinball. And here it is. It's in BASIC. And for what it does, it doesn't seem to be a very long program. So there you go. It's not thousands and thousands of lines of code. And when you run it, there's your pinball machine. And then you can So what does it say? Ziki. So there's your paddles. There's your space bar to prime the pinball. It does make noise. I may not have the sound turned up. But anyway, this is an example of what you can do with BBC Basic. So, but I'm not ever going to do anything that involved. So anyway, I've been carried on here for half an hour. I'm going to stop. But anyway, I just wanted to demonstrate uh, you can use sort of simple tools. I mean, BBC. I don't mean to say that BBC Basic is it does a lot of things, but you can do, you can make use of as much or as little of its capabilities as you like. I'll put it that way. And I made use of, you know, some of the minimum stuff. I didn't stretch it by any imagination to, the limit of what it can do. So it's fun to fool around with, fun to play with. It's easy to write code in. There's tutorials, whatever you need. So there you go. Anyway, I appreciate you watching, and thank you very much.